In this demo, we are going to use Oracle Analytics Cloud to demonstrate how we can address the data cleansing, feature engineering, and exploratory analysis stages of the data science lifecycle. I am in the role of the procurement manager, and I have a time series table including all the procurement transactions for the last 2 years. This is a great starting point for my analysis because I would like to have a high-level overview over my suppliers and procurement transactions. Before I start my exploratory analysis, let's have a look at the dataset editor. Here I can assess the quality of the data, make transformations, and also receive data enrichment recommendations from the machine. So here I can see a preview of my data, and at the top, I see the distribution of the values that are in each one of the columns. And for example, I can do some feature engineering, such as extracting year from the date. I can click on the date and get some recommendations from the machine. So for example, if I want to go ahead and extract the year, I can simply click on this. And what we'll do is it will create a new column with the year extracted for me. I can scroll across and see the distribution I have within my data set. I might come across examples where there will be some data quality issues, for example. Here in order category, we have 5% missing values. Now, I am the procurement manager, so using my know-how, I know that this can be replaced with unknown values, so I can quickly do that myself, change that missing values or null into unknown just by clicking on the missing and type unknown. What we'll do, it will replace all the missing values or null values into unknown, as you can see here. I can scroll across and change everything I need to. We can do transformations as well. And once I'm happy with the changes, I can save the results and I can go into my workbook to perform exploratory analysis to get a better understanding of the data I'm working with. So on the top of my dashboard, I see some important metrics. I have a total spend of 600,000, for example, for 98 suppliers and 9 categories. I can see total spending by supplier country, total spend by supplier ID. And then if I scroll down, I can see the total spend by date and event flag. For example, the orange line represents that it was an event or a bank holiday within that specific days. And moving forward, I can also see how much it was spent by order category and by item category. And the very bottom, I can see the distribution of the orders by total spend and total orders and delivery status.
So as a data engineer, I would want to look at data quality issues and try to correct them as much as possible. For this purpose, we use Oracle Machine Learning notebooks. And the first thing we are beginning with is we're going to be checking for null values. So overall, as we can see in our data set, there is a high number of null values, specifically on these columns that you can see here. And the first step towards correcting them is what we're going to be doing is we're going to check for aggregation consistency, which means that columns which have a common purpose and that are linked should have consistent values between them, and we can use these consistent values to correct for instances where we might have nulls. So for example, day of week, is weekend, and is event flags would be linked because they refer to the same thing, which is the day. Also supplier information like country, number of years, price index, and discounts. These would also need to be information consistent for the same supplier, which means we can use it to correct for null values. So we initially check for inconsistencies between these values. There are none at aggregation level, and then we use this sort of logic to correct the null values we've been having. And in our case, you can notice that the supplier null values are all 0 now because we were able to correct based on this logic the data already there. Now, another option we have is business logic consistency, which means that we can use, again, linked columns that share some common logic to correct for null values. In our case, we have transactions as the core idea in the data, which means that we have stuff like item quantity, item unit price, and item total price. Now, these can be used to correct null values in the sense that we already know from a business logic perspective that quantity times item price equals total price, which means that we can use this to correct for null values. And we do this after checking that indeed these three columns are consistent, and they are consistent in our case. So we apply this sort of ruling, and we boil down the number of nulls to a lower number. In our case, there are still some nulls there, but we were able to correct a majority of them. And as a last result step, what we can also do is we can decide to drop the rows where we have null values altogether. So in our case, specifically for item quantity, item unit price, and total price, we are dropping the columns where this any of these values is null, because we established that we can't correct them anymore. We would want data to be as clean as possible. So in the end, we are left with this data set, which, as you can see, has 0 nulls top to bottom. So it has went through all of the processing steps I described, and now it's very clean to be further used for other purposes. For anomaly detection, we use an Oracle machine learning anomaly detection algorithm. For our business case, we will be looking at anomalies around item quantity, item unit price, and item total price. So what we do is we use the OML implementation for anomaly detection, and as notable parameters, we use 0.03 outlier rate, which means a 3% anomaly rate we're going to be targeting. So our model will be able to single out that 3% from our data set, which it considers as being an anomaly. And we do this, and after we get the result from the model, so flagging the anomalies, we also uh, process the data to make it more usable. So we have as a result data set, an order ID, the three inputs we use, so item quantity, item unit price, item total price, the anomaly flag based on the model, so this can be either true or false as the model decided to flag them. And also very important, the confidence for the anomaly. So that means how sure the model is that that line is indeed an anomaly. And this is percentage based 0 to 100.
As a procurement manager, I know there are some abnormal values in the procurement spending, and because it's difficult to analyze the data manually, I asked for help from our data scientist who created the machine learning model for me. I got the results with the spending anomalies and quickly created this dashboard page that shows me I have 3% anomalous orders in my data set, and I can see right away the top anomalous orders with the highest confidence score. I can retrieve the same information in a tabular format with information about order ID. And I want to see more details in order to analyze these anomalies and to take immediate actions. And for example, if I right click on order ID and keep selected, I will retrieve in my order details table all the information I need for this order. For example, I see the supplier ID, I see the category item, the order category, and information about the price, the quantity sold, and so on and so forth. So what I can do is I can send this information to my team for further investigations if needed and take the appropriate actions.
So for data preparation for the purpose of supplier clustering or supplier segmentation, what we initially need to do is we need to aggregate data at supplier level, and we do so using the group by clause. So we are grouping by supplier ID, country, years, price index, and discount, which are all attributes of the supplier. And then for all of the other columns in the initial data set, we are basically feature engineering with some of the important things we would want to consider for the supplier segmentation. Stuff like the number of orders which happened in the weekend, number of orders outside of the weekend, number of the orders on a day which was an event, outside of an event, the number of items for specific categories like fashion, marketing, facility, beauty, etc., the average total price for a certain supplier, and then the category of the order. It could have been product or services, so the number on that. The various types of urgencies associated with the order, so number of orders with urgency low, urgency medium, urgency high, and the delivery was delivered on time, and other types of delivery late, delivery rejected, so the status is on the deliveries. Again, all of these aggregated at supplier level, and then what we are left in the end is a table looking like this. So it's supplier ID, which is unique. You would have all of the attributes for the supplier, but also the additional features we just created with the aggregation and the logic described. And this will be fed into the clustering model that will be able to segment basically the suppliers based on these items.
As a procurement manager, I want to segment suppliers based on their characteristics. I already talked to data scientist to create an aggregated data at supplier level, and he shared his final data with me already. This is how it looks like. I can further apply my know-how and bin the supplier years, for example, into 4 bins. Just by clicking right on supplier years, select bin. And what I would want to do is keep the 4 bins in the default settings. I will just save this, and what it will do, it will add me a new column with the supplier years. What I will do next is build supplier segments and discover different suppliers in order to optimize the procurement strategy. I will use Dataflow. It's a user-friendly interface, ETL-like, that allows me to train the machine learning model that will cluster my suppliers and then apply it to my dataset. It looks like a flow made of different steps. The first step is to load the data I got from our data scientist. Then I can add a second step to train the clustering model. I already did that, and this is how it looks like. I chose 5 clusters, and then I saved my model with under this name, _procurement clustering. Once I save and execute this, the model will be saved and available for use. What I need to do next is to create a second flow that will apply the model to my data set, and it will save the clustering result as w_procurement_clusters. As a procurement manager, I want to segment suppliers based on their characteristics. I already talked to the data scientist to create an aggregated data at supplier level, and he shared his final data with me already. After creating the necessary steps in order to build the clustering model, I am now able to get the machine learning model result and create this dashboard page to visualize the segmentation outputs. As mentioned, I wanted to segment my suppliers into 5 clusters, and I can already see that, for example, cluster 3 and cluster 4 are the top spenders, while cluster 1 spends the smallest amount of money. While in cluster 3 and cluster 4, most of the amount is spent for suppliers in the United Arab Emirates, we see that in cluster 1, most of the items come from suppliers in Turkey. If I scroll down, for the order category spend distribution, we see that the distribution is uniform across cluster with products on top, followed by services. Same applies or same is available for the item category distribution across the clusters, well, we don't see any variation. Fashion and beauty are on top for each of the clusters. If we scroll down, we also see the cluster distribution by order delivered on time versus the orders delivered late, and the order's average total price. And in the table below, we see the clustering rules. For example, cluster 1 is characterized by low supplier price index, high discounts, and low average total price with the external suppliers that we collaborate with for more than 16 years. And if I compare it to cluster 4, for example, cluster 4 has a high supplier price index, low discount, and high average total price. The suppliers are internal, and we have been collaborating with them for a period between 12 and 16 years. So this is how my supplier segmentation looks like. I think for now it's enough in order for me and my team to be able to do the strategy for next period.
For data preparation for forecasting, what we need to do is, again, we're going to use the group by function, but this time we're going to use two aggregation levels because we want to be forecasting, first of all, the total item price across all of the dates, which means we are aggregating by only the date, so group by date in this case. But also we want to be able to do this at item category level, so different forecasts for each of the different item categories. And a different group by clause that you can see here is by date and item category. And again, our main variable is the total price. So we are forecasting total price initially across all of the item categories as a whole, but also individually for each of the item categories. And the end data set looks like this. So we have day, item category, the total price, and then the category total price. So this represents the total price overall, which you can see is the same for a certain day for all of the categories, and also total price per category, which is different by category for a certain day.
As a procurement manager, I want to use Oracle Analytics Cloud to predict procurement spendings for each category and day in order to take proactive actions about spendings. I asked our data scientist to prepare a final data to be used in my citizen data scientist environment, which is the Oracle Analytics Cloud in our case. I already received the requested data, and I need to build spending forecasting models and discover expected spending patterns for the future. I'm using data flow in Oracle Analytics Cloud in order to do that. And I start by adding the data received from the data scientist. Then I choose to filter in order to get the forecast for item category beauty. This is my interest for the moment. And the next step I added is to select the columns I want to use as input for my model: order date and category total price. Then the next step is to apply the time series forecasting. And I have been doing some parameter setting. My target, or the column that I want to predict, is category total price. The time series is order date, and I want to predict it for a period of 14 days in our case. The model type I chose is ETS. We have available other two types, which is ARIMA and seasonal ARIMA. For this specific example, I chose ETS. And once this is done, I just save my data, and this will be available for visualizing the results into a dashboard page. I'm the procurement manager and I want to use Oracle Analytics Cloud to predict the procurement spendings for each category and day in order to take the appropriate actions about my procurement spendings. I asked our data scientists to prepare the data in order to be used in my environment, and I already built a forecasting model in Oracle Analytics Cloud. What I want to do now is to visualize the results. I see in my dashboard the procurement spend for beauty for the last 4 months, from December out to March, in the blue line. And then I also see the forecast for the next 7 days, represented by the black line. This will help me take the proactive actions and better plan the spendings.